Hey guys, welcome back. In section 3, we'll be studying about tree-based machine learning techniques for stock prediction. So let's start with decision trees intuition. In this video, we'll be covering what's a decision tree, how does a decision tree work, and when a decision tree can be used. So let's see what's a decision tree. So decision tree is a tree-based machine learning algorithm in which different features are used to divide the dataset into homogeneous groups. Here each independent variable becomes the node of the tree on which the dataset is split. The final goal is to create homogeneous splits such that each split can give us our final target variable. So let's take an example to understand this. Consider a place which has temperate climate. In this place, whenever it is humid and it is not windy, it rains. So let's represent this in a decision tree. So we see first whether it's humid or not. If it is not humid, we straight away know that there is no rain. So we get our first homogeneous groups in which all the dataset present is of no rain. Now consider when it is humid, we need to check whether it's windy or not. We check if it is not windy, it rains, otherwise it does not rain. Now we have three very separate homogeneous groups. First being not raining, second being raining, and third again being not raining. So this way, we took all the heuristics that were present in the data and formulated that in a form of tree which can now classify a day to be rainy day or not. So this is how we construct the decision tree. Now let's do a bit of a deep dive into this construction part. So a decision tree is developed in such a way that the homogeneity is increased at each level of the tree. Now consider a place which has tropical climate, where whenever it is humid it will rain, irrespective of the wind conditions. So here there are two ways to construct the tree. First, consider the humidity feature. If we consider the humidity feature, we straight away know that if it is humid, it will rain. If it is not humid, it will not rain. So we construct two very different and homogeneous groups straight away by taking just one feature. Now consider if we started with the windy. In that case, even if we know it's windy and not windy, we'll not know it is going to rain or it is not going to rain. So each group is not homogeneous. That means humidity is a better feature to use. And typically it will form the parent node. So eventually the algorithm trains to build a tree in which the features that divide the dataset into homogeneous groups are given the preference. Also, a tree is grown until sufficient value for a KPI is obtained. This KPI could be either R squared or adjusted R squared for regression. It could be F1 score or accuracy for classification. The number of levels in a decision tree is known as the depth of the tree. Okay, let's see when a decision tree can be used. So when the relationship between the dependent and the independent variables is non-linear, we can use a decision tree because decision trees can map a non-linear decision boundary as well. Also, if interpretability is a major factor for the model, then we can use a decision tree because in a decision tree you can backtrack every result you got. And you can see typically what value of which of your variables led to the current result. If you want to know the importance of each feature that was used, we can use a decision tree. This is really important in certain cases, like example, if you are predicting a stock market results and typically in Indian market, maybe the sentiment is driving it more. On the contrary, in the Japanese market, maybe it's the macroeconomic factors that drive it more. So if you use a decision tree, we'll be able to interpret that through the model.